Hello, welcome back. This section we are going to do integration by part. So, that's the first technique, a new technique we will learn, integration by part. Set integration by part. Suppose u and v are differentiable function. Then if you are asked to find the integral of u dv, it will be equal to u times v minus the integral of v du. So the integral u dv is viewed as the given integral, okay? And we use integration by parts to express it in terms of a new integral, which is v du. The technique is successful if the new integral can be evaluated. If it cannot, then you do another integration by part, or you can use substitution. It's depend on what type of integral you have. But basically, for example, if I'm asked to evaluate the following integral, x times e to the power of x dx, so you need to identify your u and your dv. Most of the times use u for a function that derivative can be integrated easily. Do you understand? So the presence of product in the integrand often suggests integration by parts. We split the product x e to the power of x into two factors, one of which must be identified as u and the other as dv. Okay, the power of x are often good choice for u. And the choice for dv should be easy to integrate, as I said. Okay. So in this case, I would just said let u be equal to x. If u is x, then du will be what? Dx, right? And then if I said my dv would be e to the power of x, so which means v would be what? What is the antiderivative of e to the power of x? That's still e to the power of x. So this is how integration by parts is done. So this integral that I have, which is what? X times e to the power of x dx. So you can see this is u and this is dv, right? Sorry. I have to put dx right here, okay? So that is why I will write this one as, this one would be what? We said it would be u times v, so my u is x, so x times v, v is e to the power of x. So again, it will be equal to u times v, then minus the integral of v times du. V is what? E to the power of x. And du is what? Dx. Do you understand? So this is v and this is du. And then, of course, I can easily find the antiderivative of this one, right? Which will be what? So my final answer will be x e to the power of x minus e to the power of x plus c, because the antiderivative of e to the power of x is e to the power of x, and I'm done. This will be my final answer. Okay. Next, same thing. We are asked to evaluate x times sinus x dx. So again, I would say this is my u and this is dv, right? So u is what? U is x, which means du would be dx. And dv is what? Sinus of x dx. So that means v will be equal to, what is the antiderivative of sin x? Negative cosine x. So that is why, again, if I'm asked to find the integral of x times sin x dx, it will be u times v. My u is x and my v is negative cosine x. So I will have negative x cosine x, right? Because x times negative cosine x will be negative x cosine x minus the integral of v du. Dx, right? Negative and negative will be positive. What is the antiderivative of cosine x? That is sine x plus c. So you can practice this till you get it right, okay? Do not forget, this is my, again, u dv, and this is u times v. This is v du, and that's it. Okay, so now let me make it a little bit complicated. The integral of x squared times e to the power of x dx. So in this case, again, still we have x squared times e to the power of x dx. So I have what? U times dv. So u is x squared. So that means du will be what? 2x dx. And dv is my dv is e to the power of x dx. So that means v would be, e to the power of x, right? So that is why, again, if I'm asked to integrate x squared times e to the power of x dx, I will have u times v. My u is what? X squared, and my v is, so x squared times e to the power of x minus the integral of v du. My v is e to the power of x, 2x dx, right? So you see, to be able to integrate these parts, so basically, this is again times v minus v, this is v, and this is du, right? Let me rewrite so you can see it beautifully. X squared e to the power of x minus 2 is a constant, so I can take 2 out. You know, we like it's better to read x e to the power of x dx. So you see, to find this integral, we have to use integration by parts again, because this is already solved. So you know, this will be u now, x will be u, and e to the power of x times dx will be my dv. So which means second time again, I will have x squared e to the power of x minus 2 times. If u is x, right? And let me do that before so you can see, because this is first time. So u is x, which means du will be what? Dx. Again, v is e to the power of, dv is e to the power of x dx. So that means v would be e to the power of x. So now, again, my integral will become what? It will be x squared e to the power of x minus 2, right? Parenthesis, u times v, which would be x times e to the power of x minus the integral of u, v times du. My v is e to the power of x, and du is what? Dx. Now, finally, which I will have x squared e to the power of x minus 2x e to the power of x, right? What is the antiderivative of e to the power of x? That's e to the power of x times negative 2. It will be plus 2e to the power of x. And that's it. So if you want, we can factor e to the power of x. And to make it look beautiful, e to the power of x times x squared minus 2x plus 2. See? And that's it. So now, you see, in this case, we have to do integration by parts twice to be able to integrate. So that can happen. The next one we will do also is a little bit complicated. That is integrating x sinus x e to the power of 2x dx. So to integrate this one, again, we will use integration by parts. So I will set in this case. So to integrate this one, there is no obvious choice of u and dv, okay? But if you are doing this one, because most of the time, if you integrate sinus x, it will become cosine x. If you integrate cosine x, it will come back to sin x and so on, right? So that is why I'm going to use that as my dv, because e to the power of 2x, the integration will see, you will still have e to the power of 2x, e to the power of 2x. So that will not change. So there is no obvious choice. But since that's the case, let's try this one. I would say let this will take a little bit time, okay? Let u be equal to e to the power of x, 2x, sorry. Right? Then du will be what? Then du will be 2 e to the power of 2x dx, right? And let's v be equal to, dv be so v will be what? Negative cosine of x. So that means if I do my integration by part, the integral of sine of x e to the power of 2x dx will be equal to u times v, so which will be negative cosine of x e to the power of 2x minus v du, right? My v is negative cosine of x times 2 e to the power of 2x dx. Let me rearrange this one a little bit. So basically I have negative cosine of x e to the power of 2x, right? Plus 2 cosine of x e to the power of 2x. So you see, I can see this is what I have. So I still have to integrate this one. I will use what integration by parts, but you can imagine, like you can predict what you will have. You will still have another integral, right? So I'm going to be at some point, I'm going to have some equation to solve. Like for example, if I said, let this be my first equation, right? But then I will go ahead and integrate this part. I'm going to take this part, which is the integral of cosine of x e times e to the power of 2x dx. I'm going to be using the same thing, okay? I will set let u be equal to e to the power of 2x. Then my du will be what? 2e to the power of 2x. And then dv is cosine x dx. Then v will be sine of x, right? So if I do that, my integral will become now. That integral. So that means the integral of cosine of x e to the power of 2x dx also will become what? U times v, so it will be sine of x e to the power of 2x, right? Minus the integral of v times du. So sine of x times 2e to the power of 2x dx. So basically, that will be what? Sine of x e to the power of 2x minus 2 times the integral of sines of, sines of x e to the power of 2x dx, right? So if you look, this bring me back to my original integral I was solving, right? Because we already know sines of integral of sines x e to the power of 2x is equal to this one, right? Let me make it a blue color so you can see. Sines x e to the power of 2x will give me this one. So, or we just solve cosines of x e to the power of 2x from that equation, which is this one, and then we got this. So I'm going to substitute now my integral of cosines of x e to the power of 2x dx right here. Okay, so again, please pay attention. So I'm going to call this one my equation 2. Equation 2 is what? This is the integral of cosines of x e to the power of 2x dx. Or equation 1 is what? That's what we are solving. We are solving equation 1. Do not forget. Sines of x e to the power of 2x. But we use this, right? So I'm going to substitute cosines, integral of cosines x e to the power of 2x into equation 1. So now, result in equation 1. That's what I'm doing, okay? So if I do that, of course, we know equation 1 is what? The integral of sines x e to the power of 2x dx, right? Which was equal to what? We already have this term, negative cosines x e to the power of 2x, negative e to the power of 2x. Now what do we have? Plus 2 times, plus 2 times the integral of cosines x e to the power of 2x dx, or we just find the integral of cosines of x e to the power of 2x dx is what? That is sines x. So this is my substitution. Let me use a green so to substitute. Sines of x e to the power of 2x minus 2 integral of sines x e to the power of 2x dx, right? This is fun. If you get confused, please pause the video and think about what we just did. We just substitute, because once I find the original integration, we still have this one. So we have to integrate this. So I took this and find its integral, which gave us this, right? We got this one from there. So I have to substitute it back. So that's the only thing I did. So I substitute the result into the equation 1. Now, look what will happen. So we have the integral of sines x e to the power of 2x dx will be what? Negative cosines of x e to the power of 2x plus 2 sines x e to the power of 2x minus 4 integral of sines of x e to the power of 2x dx. Do not forget, the original integral that we are solving is sines of integral of sines x e to the power of dx. But do you see we have integral of sines x e to the power of 2x dx also here? So what about if I add? So I'm going to isolate the integral of sines x e to the power of 2x in one side. So I will add what? 4 sines x e to the power of 2x dx on both sides, right? So if I do that, 1 integral sines x e to the power of 2x dx plus 4 integral sines x e to the power of 2x dx will give me 5. And sines integral of sines x e to the power of 2x dx. Right? It should be minus cosine x e to the power of 2x plus 2 sines of x e to the power of 2x. Right? So I will add plus c because, again, do not forget at the end, okay? But I don't just want you to think the indefinite integral, you always have to add c. So I'm going to divide everything by 5. So my final answer will be uh, sines of x e, the integral of sines of x e to the power of 2x dx would be equal to negative 1 over 5 times cosines of x e to the power of 2x plus 2 divided by 5 sines of x e to the power of 2x plus c. So if you want, you can factor 1 over 5 e to the power of 2x. Okay? And that will be my final answer. Okay, so now let's move to the next one. So if you understand this preview example, this is just integration by part for definite integral. So it's the same technique, just the integral is, you have the limits of integration in this case, and that's it. But all the rest are the same, okay? So you don't have to overthink on this one. Like for example, if I'm asked, let u and v be differentiable function, then the integral from a to b ux times v prime of x dx is equal to u of x times v of x, the integral a to b minus sorry, you substitute a and b minus the integral from a to b vx times u prime of x dx. So it's same thing, okay? Let's do this example so you can see it's same thing. So if I'm asked to evaluate the integral from 1 to 2 ln of x dx, so you see in this case, we don't have the antiderivative of ln yet, right? So you will assume you have 1 times ln x dx, which is what? If you don't see anything, that means you have what? A 1 there, right? So that is why you will use your u as ln. So I will say let u be equal to ln of x, then du will be what? 1 over x dx, right? Then we would assume that dv is just dx, 1 dx. So that means v will be equal to what? X. So by substituting now, you will see the integral from 1 to 2 ln of x dx. This is my u, and this is my dv. Will be equal to u times v. So which will be x ln of x from 1 to 2, right? Minus v times du. So minus x times 1 over x dx as the integral go from 1 to 2. Okay? So if I substitute right here, I will get what? Substitute 2, we'll get 2 ln of 2. If I substitute 1 times ln of 1, which is 0, right? So minus 0. So do not forget, this is u times v, this is du. So now minus the integral x times 1 divided by x is what? 1, right? So which will give me 2 ln of 2. What is the antiderivative of 1? That is minus x going from 1 to 2. So that means my final answer will be sorry. Let me erase this one and make it more beautiful. Okay, so now I have 2 ln of 2 minus the antiderivative of this, which would be x, the antiderivative of integral of 1 to 2 dx will be, and then if I substitute, I will get 2 ln of 2 minus 2 minus 1. 2 minus 1 is 1. And then, hold on, give me 1 second. I think I make a mistake right here. No, it's cool. 2 minus 1 is 1. So my final answer will be 2 ln of 2 minus 1. And then that's it. Okay. So don't forget, you can memorize this one anytime if you are asked to find the antiderivative of ln x dx, just know your answer will always be ln of x times ln x minus x plus c. Okay, like for example, you can see when I was asked to find the integral from 1 to 2 ln of x dx, I just said if I remember this one, the answer would be x ln of x minus x from 1 to 2, because this is definite, so you don't need c. And if I substitute my 2, I will get 2 ln of 2 minus 2 minus, if I substitute 1, I will get 1 times ln of 1 minus 1, right? So which will give us what? 2 ln of 2 minus 2. Ln of 1 is 0, so plus 1, and that gives me exactly what I have. So you can memorize this one and use it when you need, okay? That's it for this section. I will see you in the next one.